Hi everyone, thank you for joining. I really hope that you're all staying safe at home. Now, today we're going to speak about observability in serverless applications, how to build more, fix faster, and troubleshoot less. I'm Ribenzaft, the co-founder and CTO at Epsagon, and I'm also an AWS serverless hero, which means that I'm really a fan of Lambda functions and all this serverless ecosystem. You can follow me on Twitter to hear more about serverless or any other cool stuff, geeky stuff. And over the right hand side you can see me looking for whales in Hawaii, but unfortunately I couldn't find any. So let's get going. Today we'll discuss about three main topics, or actually two main topics, and one of them is more of an example. The first one is observability and best practices. The second one is distributed tracing as a crucial part of observability. And the last one will be a live demo, because we can't do this without a demo. Now, when we're thinking about software, we already understand that we made some changes. We started with a host-based monolithic applications, and then we broke down our application into more distributed ones, which created and introduced some complexity. But now, with cloud and serverless, everything becomes so managed. The host is abstracted. There is no more host for SNS or SQS or S3 or Lambda functions, and obviously not for third-party APIs. So our application's becoming more and more complex and hard to understand, which really impacts us, the engineers and the DevOps. Today, troubleshooting becomes much more pain because we have tons of logs in so many places and we need to correlate between them, and all this process can take us hours or even days to troubleshoot complex scenarios, as we can see on the right hand side, where we have a user which had some error in the application, and now we need to understand the whole flow and the whole process from end to end. This becomes a pain. Secondly, how do we monitor such applications? It's no more like CPU and memory stats. Now it's about the connectivity, how the whole architecture looks like in production, and what impacts our performance for bottlenecks or any other issues. And also, when combining both, this also impacts our development, because if we're not doing it good in production, development iterations are becoming slower and slower, and that's not what we're looking for when we're doing serverless. When we're talking about observability, we're having three pillars in mind. One of them is the metrics, which we can aggregate, from multiple sources, multiple dimensions like CPU and memory and calls and stats and so on. We'll talk about it. Secondly, we're thinking about logging, because when we're having a problem, metrics are just the symptom, and now we need to troubleshoot and understand exactly what happened. And the last, and I think the most crucial pillar of observability today, is tracing, that helps us to correlate between the metrics and the logs and the different services. And I think the main problem today is that you have one different tool for every scope here, for every pillar, and it's not the best practice, because you're just finding yourself correlating between one service to another. So I think that having all of them under the same tool can really help engineering and ops teams leverage more. Now, before we dive into the distributed tracing part, let's speak about some best practices in monitoring and logging. So first of all, for monitoring, I think it's the most obvious that you want to have all monitoring under the same dashboard. You don't want to have part of your monitoring in tool A and the other part in tool B, and some here and some there. Also, make sure to define your own critical metrics to set up the thresholds, because when you wake up at 4 a.m. in the morning and you need to troubleshoot something, it better be a right damn thing to troubleshoot. Otherwise, just set thresholds, because it creates this kind of alert fatigue. Also, use some custom business metrics, like how many items were in the cart, or what's the duration of the user watched this episode, because this will help you troubleshoot and gain some more information, not only for the engineering team but for the overall team as well. And also make sure that once you're monitoring also your application metrics, not only the infrastructure ones. For example, like what's the average duration for HTTP calls that we're making? I would say even more percentiles, like P99 or even more than that. Also, what's the number of 500 or 400 errors that we're getting from our services? These are crucial metrics to look for. In terms of logging, so first thing, and this is very crucial in logging, don't just log random text. Log it in a JSON or a dictionary format with all the metadata. For example, what's the service name or the function name? Which stage am I running at? What kind of event am I handling at? All these things are important for you to be able to then when you're looking at the log, you'll be able to understand exactly the context and the metadata that you're looking at. Also try to automate as much as possible the process of logging. Capture all the metadata in an automated way. Do things as a middleware before and after each and every call that you're making, because logging is a manual work, and the more manual work that you have means that you're not working on the important things. And also, same as monitoring, try to centralize all of the loggings into a single place that will give you the ability to search and aggregate and analyze and alert, and also index the right fields that you're interested in, so you'll be able to plot interesting charts for your business. With that best practices, something is still very much missing over here. How do I correlate between metrics and logs? They're still on the different tools, and now when I'm having a problem in metrics, how do I know which logs am I supposed to look at in order to troubleshoot it? Also, how do I correlate between different services, different functions, or different resources? Because each component takes care for it individually, but I need to see the overall picture from end to end. That's exactly where distributed tracing comes to help us. Distributed tracing honestly just tells a story of how an event or a request moving in our system. As we can see on the right hand side, a client talks to a load balancer, calls off service, billing service, some other resources. We want to be able to visualize it in that way, not just in logs, because logs are hard to read. In order to do distributed tracing, we need to do two parts. The first part is to generate the traces, and the second part is to ingest it and have a client to visualize it and do something with it. So most of the tools can be used as an open source, part of the CNCF, the Cloud Native Computing Foundation. Two relevant ones for generating traces are Open Tracing and Open Telemetry. And for ingestion in the client, we got Jaeger, which is part of the CNCF, and Zipkin, which is not. We're going to talk about Open Tracing and Jaeger now. In order to generate traces, we need first to instrument every call. It means that every time that I'm calling to AWS SDK, to HTTP calls, to PostgreSDB, or every time I'm having an incoming request to my Flask or Express or Spring, I need to be able to capture the information in an automated way. That's called instrumentation. Now, when I'm having a way to capture it, I need to create a span, and this is from the terminology of open tracing. I need to create a span which tells me you have this operation on this resource for this amount of time. I need to add some context to that span that will tell me what exactly am I doing. For example, if I'm calling to an HTTP resource, what's the URL that I'm calling to? What's in the payload or the status code that I'm getting in response? And also, in order to actually do distributed tracing, I need to inject and extract IDs in relevant calls. It means that if I'm calling to an HTTP resource, which apparently is API gateway, which triggers another Lambda function, I need to inject some correlation ID and extract it on the other hand. This is a lot of work, and just as a quick example in Python, I know that it's hard to read, I know that it's long, but this is the most basic example how to trace incoming HTTP request, and it's a lot of work to do manually. Many people think that, oh, open source, it's very easy, I'm gonna just plug it in and it's gonna work. But no, this is just a framework that allows you to train yourself and start coding tracing. Now we need to take care for the part of shipping the tracing somewhere and ingest them and visualize them and do something with them. So now we need an ingestion system according to our scale. Is it millions of requests a month, or billions, or tens of billions? This is something that we need to bear in mind. We also need to index the context and the tags that we're adding to each and every text, because we want to filter by that and search and analyze and aggregate this information. We also need to visualize trace somehow, either in a timeline or waterfall chart or in a graph view. We want to set up alerts when something bad happens, and there are lots of more things that we can ask for. Today, Jaeger offers the most basic things of ingesting. Obviously, you take care for the scaling and visualizing timeline, which is great, but I don't think it's enough. But when you're doing it right, you can actually see a request coming all the way from the front end to the back end, and all of the resources that you're using, like Redis or databases and so on. This is much more helpful than logs already. Few more things of best practices in distributed tracing. Make sure to tag your traces as much as possible. Add them things like identifiers, like user ID, customer ID, device ID, item ID. All these things will help you to search and pinpoint and analyze things that your users are doing or devices are doing in your application. Also add some flow control taggings, like what's the event type that I'm handling, what's the business logic that we're doing right now. This, for example, will be able to plot you like a chart of how many times am I doing this kind of events and how long on average does this take. And also business metrics, just as we spoke about in metrics, like items in carts, minutes you watched. These things will help you to further investigate what's going on and again, analyze things that are happening in your application. Also, I think it's worth mentioning that if you're already putting some context, why not put all of the context? Put all of your payload into the trace itself. For example, let's put the HTTP headers or body into the context. That way we don't need to manually tag IDs or anything else. And also when we will troubleshoot, we'll see exactly what happened. Or maybe the query or the query from a NoSQL or SQL database. This will help me understand which kind of query is taking so slow, or what kind of key in the DynamoDB is taking the most of time. Or maybe the response payload from an HTTP call that I'm making to my Stripe service, because that's helped me to investigate much faster. And also tracing can act as a glue. Once you're having a trace, you can quickly jump to the logs if you're implementing it correctly. And also you can jump in between the trace and the environment. So you can go back and forth from your Lambda function to the traces and vice versa to see the metrics of what's going on at the trace at the same time. Now that we understand what's the best practices, let's think of what would be a good solution to use, or what a good solution might introduce us. In terms of observability, so we're thinking, especially for serverless, that we really need something automated. We understand that having monitoring, tracing, logging, and all of these things all together will consume a lot of time for us. And when we're doing serverless, we want to focus on the best thing that we can do, which is the application for our business. So automated and zero setup and zero maintenance is crucial here. Also, we want something to support all of our environments. For example, Lambda function, AppSync APIs, Fargate, which is also a serverless kind of thing, and also a managed Kubernetes cluster. We want to have all of them under the same dashboard. We want to be able to connect every request from every service in every framework and in every environment. So for example, if I'm having an incoming request from API gateway to a Lambda function, then goes to SNS, to another Lambda function or another consumer, all of these things should be connected automatically. And we want to be able to search and analyze the data that's coming from the application, from the metrics, from the traces, because this is the most important part. And also something that helps us to troubleshoot much faster the kind of issues, something that gives us a good triage on any problem that happens. With Epsagon, you're getting an immediate value add. With the simple integration that we'll see in a minute, you get a really reduction in the troubleshooting time, more than 90%. The setup is super simple. In 5 minutes, you're getting this kind of observability, everything that we spoke about, into your environment. And you also reduce the amount of errors that you're having because you're more up to what's going on in your environment. In terms of the integration, so it's simple, super simple. You connect your cloud environment. This can be today any AWS account and as much as you want, or a Kubernetes cluster. This is, by the way, give you free metrics, insights, and alerts to your environment, and it's completely free at any scale. And also comes the tracing part, or the auto instrumentation part, which today we support Python, Node, Java, .NET, and Go. And for example, for Lambda function, we got a simple click integration that you can point it out through the Epsagon dashboard, and you got tracing, and that's it. No redeployments, no changes in the code whatsoever. And we're also enterprise ready. We're working with hundreds of customers already. We're SOC 2 certified, ISO certified, HIPAA compliant, and GDPR compliant. And we're an advanced technology partners with 3 competencies, running on AWS and selling through the marketplace if needed. I think it's time for a demo now. So as you can see now, move to the demo environment, which is demo.epsagon.com. Anyone can reach it. Even now, it's open for everybody. So what we'll be able to see right now is that in this demo environment, we already integrated several AWS accounts, and we're getting or leveraging this kind of free monitoring. We're able to see all of our functions from all of our AWS accounts, from all regions, to see what triggers each and every function, and to start and see some metrics about our functions, like how many invocations, how many errors, how many timeouts, and how many out of memories, which are pretty unique to Epsagon. Nobody today shows you how many timeouts or out of memories are you getting. Nevertheless, nobody will alert you for such problems. And also in these times, looking at the cost, which is really tied to the performance of your functions, this is super crucial. So being able to look at the cost of your function becomes really crucial these days, and Epsagon is already doing and alerting on that. Now let me take you through a scenario of troubleshooting a problem. I'm starting by the errors column, and I'm going to get to the second function, which got 9,000 errors in the last week, which is a lot and something probably not working very well. This function named post analysis. So I'm going to get into this function, and I'll be able to see two parts. One of them is the performance metrics, invocations and errors, all kinds of them, memory usage and duration statistics, which by the way all presented in percentiles, which makes it much easier for me to detect spikes or anomalies or any issue in my code. The second part is the invocations table. Every time your function will get an invocation, you'll see that listed over here with the according request ID, the resources that took part, the time it happened, the duration, the used memory, and the status. In Epsagon, it's super easy to filter anything you want. You don't need to pre-index, or you don't need to do anything. For example, I can filter only exceptions or timeout. I can filter long-running invocations or a specific request ID. I can also just filter in the logs of this specific function if I'm interested into. As you can see, this function is having a lot of exception in the recent time. So I'm gonna look at the CloudWatch logs of this specific invocation, and with Epsagon it's pretty simple. We don't store the logs, we just pull them for you, so you don't need to look for the right log group or log stream and sift your way through that. You're just getting all the logs to you, and you can again filter them to understand what happened. With Epsagon and with observability, we understand that logging and metrics are not enough. And by the way, everything that we've showed so far is free. But now we need to dig into the actual problems and see a distributed trace from one end to another. So I've clicked on the request ID, and now I'll be able to see a visualized story. This event that's ended up with an exception on Lambda, which by the way, I can see the full traceback and get alert for it. I can drill back now backwards, and first of all understand that this kind of problem happened 3 times in a row, this kind of a retry attempt, to see what's going on over the SNS and see the payload, because for example we mentioned that tracing with payload helps us to troubleshoot, and since we're doing distributed tracing, even the most distributed events are aggregated all the way here. So I can see exactly any call that I make to HTTP resources, any Lambda function, including the logs of each and every invocation, labels, headers, payloads, and so on. This is very easy to troubleshoot and understand. So now we're gonna jump to the trace search. This screen allows us to search any kind of traces, any kind of payload in all of our traces and things that we're getting into our application. So I'm gonna filter by a specific user ID that happens to have some problems. And I'm going to look only for kind of errors that this user is having. So I'm gonna hit the search button, and I'll be able to see 2 things. First of all, how many errors is having over time, which is a lot by the way, and what's the average duration that it takes for him to get this kind of errors. And I'll be able to see each and every event that happened in here, and unlike logs where I find the logs and now I need to correlate it, every event that I'll click in here will reveal with me the full story. So this is the actual story of that user ID happened with that specific request type. So it makes it much more easy for me to troubleshoot, get the logs, and understand exactly what happened. Also, Epsagon aggregates all of your issues all together into the issues manager. So it's easy for you to understand what kind of problems are you having, how often do they happen, whether you got alerted or if you want to mute this kind of alert and open it up in Jira or other sources. And obviously, Epsagon will ship you alerts for any kind of problem that you're having with your serverless environment automatically to Slack, PagerDuty, and other integrations that you can see on the screen. And just to finalize with, nothing is complete with being able to visualize complex applications. So here we got some sample applications. I'm going to go back to the blog site that we just saw before, and being able to visualize it from end to end and understand all of the components, all of the resources that we're having, what's communicating with one another, and what's the performance of each and every resource, it's crucial. So even if we're interested in drilling down to a specific Lambda function, we can easily understand and break down the performance of it to understand how long things takes from end to end, and where do we spend most of our time in this kind of metrics out there. For example, the amount of calls and errors, the average duration breakdown to understand what takes the most out of this Lambda. So that really covers most of Epsagon out here. And let's just finish with some summary. So we understand that modern application, especially the serverless one, requires more than just basic monitoring, and distributed tracing becomes really the most crucial part in such environments. And I think as a good recommendation for you guys, try to not implement your own solutions. You don't want to focus on it, especially if you pick the serverless way to do so. And just for you, if you want to start now, we're having some extra benefits to all attendees that are going to sign up today. You can see the link over here. Just reference yourself as Serverless Nordics, and we support all kinds of environments for you. Thank you very much.